In this video, we're going to set up the study and run it. For this, we're going to follow our steps one after the other. First is to prepare the part. We have the part here and it's ready to go. We can notice that the part was created using Weldemann's functions in SolidWorks, meaning that the software will likely interpret it as a beam once we start a simulation study. The second step is to assign the material. For this part, the material is already set to steel AISI 1020. The third step is to start a new study. So let's go ahead and start a static simulation study. So I'll go to the Simulation tab, select New Study, select Static, and click on the green check mark. And here are a couple of aspects we can notice once we do that. First, the part itself is listed under the cut list folder. So if I expand that, we can see the name of the part and the material it is assigned. We will also see an icon of a beam next to the part, indicating that the part is treated as a beam. The second thing we can notice is at the end of the beam, we can see yellowish or dirty green spheres. Those indicates the joints of the beam. So whenever we apply fixtures, for example, we will apply them to those joints. In a way, this simulates the most common types of beams which gets connected at the endpoints. In addition to those spheres, we can see a joint group entry at the simulation tree. Now we can move to the fourth step and apply contact conditions. However, this is not applicable here since we only have one single body part. Step number 5 is to apply the fixtures. So let's go ahead and do that according to the problem statement. I'll go to Fixtures, right click, and then select Fixed Geometry. I'll make sure the selection is at Fixed Geometry, and then here in the space, I can select the two joints, which are the endpoints. So I have this joint here and this joint here. Now what this will do is it will fix those two joints. And then I can click on the green check mark, and that's it for the fixtures. Step number 6 is to apply the load. In our problem statement, we have a load of 2000 newtons going across the beam. So let's apply that. I'll right click on external loads, select force, and then here on the selections, you notice we have a number of options. The first one is vertices or points. The second one is joints. The third one is beams. So I'll go ahead and select the beam option since we're going to apply that throughout the beam. And then simply select the beam itself. And now we have the beam listed here. And then here we can apply the direction of the force. So I'll select this space for directions, open up my design tree, and select the front plane. We can make sure to change the units. So I'll change that to SI, and that will display them as Newton. And then under the force, we will note that we have 3 options that indicate the direction of the force. So in my example, we selected the front plane as a direction indicator. So I can select the last option, which says normal to plane. And this will give us some arrows indicating the direction of the force. A lot of the times we might not get that direction correct in the first try. In that case, what we can do is we can do trial and error. So if I can open up this direction here, you'll notice the arrow is going sideways. That's not our direction, so I can just toggle it off. So here in the force, I will write in 2000, since that's the force we are given. Keep in mind that the force will be distributed across the beam. So this 2000 Newton will be distributed equally across the beam. We can also set up the force to be a function of unit length. If we want to do that, we can select this option here that says per unit length. So if I click on that, you will notice the units changes from Newton to Newton per meter. So in case that is a value we're given, we can do that as well. So let me go ahead and unclick that since that's not what we're looking for. And now we have the force set up. I can go ahead and click on the green check mark. Step number 7 is to create the mesh. So I'll go ahead and right click on the mesh and select Create Mesh, and this will create the mesh. Note that once we do that, the shape of the beam might become different. There's nothing wrong with that. This is just SOLIDWORKS trying to simplify the model to save on some processing power. And because it is a one-dimensional beam, this is the simplification SOLIDWORKS does for us. We also have the option of changing the beam to its original shape here in the mesh plot. To do that, I can right-click on this quality plot and then select Render Beam Profile. And once we do that, we get our original shape with our mesh in it. Step number 8 is to run the study. So let's go ahead and click on Run the Study. And by this, we get our results. And by this, we can conclude this video on setting up and running a beam study.